Okay, this problem, 4.8 to 4.10 review, calculators not allowed, number 5, is very similar to number 4 in that we're dealing with particle motion. What's new is that we're starting with the acceleration instead of with the velocity, and the question is still asking for the position function. So that means instead of going backwards and doing the antiderivative one time, we have to do it twice. So we can start with our acceleration curve and do the antiderivative one time, and when I do that I'll get the velocity, because what do I take the derivative of that gives me the acceleration? That's my velocity. So I move through the constant, hit the power, add 1, divide by the new power, move through the constant, put the t on, and then add a constant. Because I'm going to have to do this twice, I'm going to put a c sub 1. Now in order to nail down that c sub 1, I need to know information about a point on the velocity curve. So if I read up here, it says the velocity is 25 when t is 3. So that means that I get an output of 25 when I plug in a t is 3. So here I did 6 over 2, gave me that 3 in front. Then I'm going to square the 3 minus 2 times the 3 plus c sub 1. So that gives me 25 is, there's 9 times 3 is 27 minus 6 plus c sub 1. If I solve for c sub 1, that's a 21. Moved it to the other side, I get a c sub 1 is 4. So now I need to use the antiderivative again. So I have my v of t nailed down as a 3t squared minus a 2t plus 4. The goal is to find the position. So I need to ask myself, what did I take the derivative of that gave me the velocity? Well, the answer to that one is the position function. So the antiderivative of this, I'll move through the constant, hit the power and add 1, divide by the new power. Same thing here, move through the constant, hit the power and add 1, divide by the new power. Hit the constant, multiply by a t, and then add my second c. Well, on this one, if I simplify, I end up with a t cubed minus a t squared plus a 4t plus that second constant. In order to nail down the second constant, I need to know information about a point on the position curve. So I come back up here, it says the position is 10 when time is 1. So that means my position will be 10 when the time is 1. So I plug that 1 in. I add this together, I get a 4, so c sub 2 is going to be 6. And then I can write the equation for my position curve by plugging the c back in. So I have a t cubed minus a t squared plus a 4t plus a 6. And I'm done. So now let's do the same process with part B. Part B says the acceleration is given, and again we have a point on the velocity, a point on the position, and the goal is to find the position. So we got to go backwards twice. If I go backwards from t plus the cosine of t, what did I take the derivative of that gave me this? I will have a t squared over 2 plus a sine of t plus some constant. To nail down the constant, I use the information about the velocity. So the velocity is 1, so v of t will be 1 when time is 0. So plug in 0, I get a 0 plus a 0 plus c sub 1, so that means c sub 1 is going to be 1, and I can write down my velocity curve as t squared over 2 plus sine of t plus 1. Now, since the goal is to find the position, I got to do the antiderivative one more time. So antiderivative of v of t, or what did I take the derivative of that gave me velocity, is my position curve. So x of t will be the constant, add 1 to the power, divide by the new power. What did I take the derivative of that gave me sine? Well, that's a negative cosine. What did I take the derivative of that gave me a 1? That's just a t, and then I add my second constant. To nail down that second constant, I use the fact that the position at time is 0 is 2. So the position will be 2 when the time is 0. So plug in 0 here, plug in 0 here, plug in 0 here. Oops. So that means c sub 2 is going to be 3. So if I finish up, my x of t is a t cubed over 6 minus a cosine of t plus a t plus a 3. Last one, same process, except now we've got an e and a little bit of chain rule backwards. So acceleration is that 4e to the 2t. So my velocity will move through the constant, hit the e, leave it alone, and then divide by the derivative of that inside. And then we'll add a c sub 1. I told you when t is 0, the particle's at the point, so that's a position information, and moving with a velocity of negative 2. So that means I'll have a negative 2 come out of the velocity curve when t is 0. Well, e to the 0 is a 1, so that's a 4 over 2 is a 2 plus a c sub 1. That means c sub 1 is a negative 4. So I currently have velocity equaling a 2e to the 2t minus a 4. So the antiderivative again will give me the position curve, move through the constant, hit the e, leave it alone, divide by the derivative of the inside, hit the constant, tack on a t, and add that second constant. To nail down the second constant, I need to use a point that is on the position curve. So when time was 0, the position was x equals 2. So I can replace x with 2 when time is 0. So this will be a 1. So 2 over 2 is a 1 minus a 4 times 0 plus a c sub 2. So I find that c sub 2 is equal to 1, and I can write my position curve now. E to the 2t minus 4t plus a 1. Now the last thing says I want to find the position of the particle when t equals 1/2. So I've nailed down that position curve. To answer the question, I need to plug in a 1/2. So x of 1/2 will be e to the 2 times a half, that's just e to the 1, minus 4 times a half, which is 2, plus a 1. So I end up with an e minus a 1, which is my final answer.